Hello and welcome to another free code session. My name is Jason Bach, and I've decided to do the rest of the analysis of all these other assemblies and packages that I've been looking at because there's a lot of them and I got a whole bunch more I can do. Trying to get through all this is going to take quite a long time. I feel like the last couple of episodes have been, just me talking about some of the things I've done off camera and then looking at this and going, I need more time to look at this. So it's not ideal in terms of what I want to present. And again, a lot of this is me trying something out, struggling with it, putting new code in and features and stuff like that. But with this stuff, it gets a little bit more cerebral or just time consuming as well. So what I'm going to do, and in fact, I have time off from when I'm recording this episode. I've got like 3 or 4 days off now, and I was considering going on a bike ride down south in Minnesota, but the weather's kind of turning, and I don't think it'll work schedule-wise. So I think what I'm going to do is just spend a lot of my time having fun, and I do consider this to be fun. I like problems like this of just going through this stuff and finding more issues and trying to solve them. So, the next episode will be me saying, okay, let's go through and review what it is that I've solved. Okay. And the things that I fixed. So, and that might take more than the 2 or 3 days I have now available. I might be having to spend even more time on this, but that's the plan, at least right now. Now, I don't remember in the last episode or not if I talked about this, but I did have a way I think I did, where I talked about adding this test with code, which makes it a lot easier to really narrow in on these cases where I have to give a certain type for something. And it makes it easier in times and cases where I've got to be very specific as to what types I'm passing in for generics and stuff like that. So the one that I'm tackling right now, this is kind of a doozy, and this, I kind of have an idea now as to what the problem is, sort of. Not entirely sure I quite get what's going on, but at least I've now been able to narrow down what's doing so I can eventually create a case. I have a code case separate from MOQ that I can do this with. And do I have it up here? Of course not. Why would I keep it up? Because, I think I posted it in a group somewhere. Hold on. Okay. Yes. Saved it. So here's the case. This is basically what you're seeing in MOQ, which is you have the mock type itself, non-generic, having an abstract method called as with a type. It's actually T interface. And it returns a generic version of the class base class of T that's subclassing base class. That's kind of weird to me. I'm like, why would you do that? I'm guessing there's a reason. I just don't know what it is. But be that as it may, the case becomes, and this was an interesting one, is if you override it here, my logic is essentially finding these two methods, both of which are available, but the return types are actually considered to be different. And I mostly can get that because this T type is maybe not the same as this T type. These two types are not the same types, even though to me they look like, yes, they should be exactly the same type. If I made T type something like customer, they'd both be base class of customer, but that's not how it works because these are open generics. And I'm guessing that's why both in reflection, that's what I'm doing here, and when you're actually in the Roslyn API, these are coming back. The symbols actually in the Roslyn API, the semantic model, are coming back as being false as well. So it's the same thing in both worlds. I don't use reflection in rocks. At least I don't think I do, not as a driving force of all the source generation. But in any event, so what happens is that when I do this match on the methods, it's thinking it differs by return type only. And so then it goes into this weird thing where not weird, but it handles it in a different way. And in fact, if I have the code up here, which I believe I do, yeah, it's the match here. And if I go into the match, it will come back as saying differ by return type only. And so what happens is it says it doesn't find a method to remove because it's not exact. And then it does this logic here, and basically it adds it in again. And so what's ending up happening is, I believe you see here's an as method, and then you also see an as method here, and the same thing happens down, I believe, in here with these methods, and that's where it starts saying things like, you have, this already showing up. The funny thing is that it's not showing up in the actual mock of object. It's actually showing up in the extension methods, which to me is kind of weird. Why would it not show up above here as being an error? You would think it would be, because they both override mock T of interface as that, where T is, it's the same exact thing. So that it's just wrong. We shouldn't find these two. We should only find one. And so now I've got the problem of saying, well, how do I handle this? They are considered to be different types, but finding the method, when I go through the inheritance hierarchy, I'm looking for ordinary methods that can be referenced by name, and they're not static and they can be seen. Now, I don't know why I do this if here, but I'm basically saying it has to be abstract, or it has to be an override, or it has to be a virtual. Okay. And the type can't be a record, or the hierarchy method name can't be equal to object. Okay. So then I go through and try to find matches. Now, I have to be really careful here, because I don't want to break something, but then again, that's why we have branches and committing and all this other stuff. So I want to be fairly unobtrusive, if the right word is. And again, I don't even know if I'm going to be able to figure this out in this episode. And if not, well, then the next one will include this one as well. But yeah, this is the tricky problem, is my match here. If I look at the match, these are coming back as being, they're not equal. And so they only differ by return type. And I get what this is saying. If by the rules of C# that they shouldn't be equal, then that makes sense. I'm not disputing that. But what I need to do is say, well, wait a minute, this gives me two methods that are exactly alike, and I can't have that. So I'm wondering if I can get to this point and say, what happens if the names are equal? Is that good? I don't think so. I don't think that's a good thing to do. The way we're matching these is we both first look at the names of the methods, and then we say if they're not equal, then obviously they don't match. Okay. Now we have to look at the parameters. And I'm wondering if I should consider just type parameters as well. That wouldn't help in this case, but that type parameters should also be included, because you could have, like you could do something like have a method void foo of t, takes an int of a and then does whatever. And you could also have a void of foo that takes an int of a and does whatever. I don't know if my logic would actually see that as different or not, because we're checking the parameters. We're not looking at the type parameters. So that's just another case that came to mind is, well, wait a minute, are they actually the same or not? So now in this case, we don't have any parameters with the as. They're zero parameters. So then we just immediately fall into this return type. And again, they come back as being different. If they came back as being exactly the same, then we'd be golden, but that's not what's happening here. And again, that's where I'm coming back and looking at it going, well, if the name of the method, if like the entire name of the method, if they were exactly the same, then it would be exact. Like you could come up here and say, well, if I found, and as you see in the generated code, we're seeing that the method looks like this, and that's the same thing, I believe. Why is it not highlighting that? Mock T interface, mock T interface. I thought that did that. Like if you found something that, yeah, like as, yeah, and then I included that. Well, it doesn't find this either, but this is definitely, like I find it as another method name. If the method name, like the display name of it came through as being exactly the same, well, then to me, that is a match. Maybe that's not 100% correct, but I would take it as being a match. So I have a test with type here. Let's get back to, let's first of all, make sure. Yeah. Okay, good. Let's come into here where we're trying to do this. And we want to be, we will only want to, no, not here. We want to find where the hierarchy method is the one above. And then once we get into that, we want to step into match. Actually at that point, I'd want to say, do the names just equal? Like how specific does this get? So let's see what happens when we get into the debugger here. And while this is going, I was thinking, what would happen if you had two methods that had like customer as the type of one of the parameters and customer as the type of one of the parameters, but they're two different types. And I'm thinking, I don't think you could get into that case because how would you be able to resolve the two? They can't be aliases. They'd alias the same thing. So that would actually be like a compiler error. So I don't think I'd really care about that. Okay, so as you can see here, we haven't found any yet, and we're just doing the object one for now. Okay. And so now we find equals, we find get hash code on get object. And now this is on the mock one, which we still only have 4. So this isn't so we haven't added this one yet. Like if we look at all these, I think the last one we just added was on get. Yeah, so we haven't added this one yet. Okay. So now we come through again, and now we have toString and on get object. And now here's as, and I think this is the one that we care about because there should be, here's the as. Yes. Okay. So this is the one that we actually want to dive into. Okay. And so now let's do that. Let's step in, and we should step into here. Okay. And so now this is equals, and this one should be the as. Okay. So now we just want to watch self to where we actually get a as. So that's as, and that's as. So just because I'm curious, self do display. I can't even, not parts to display string. Okay. What does that look like? That's unfortunate. Other that to display string. That's unfortunate because they're not going to be equal, but that's not what we want. We want some way for this thing to be like if I said metadata name here, what would that look like? As, that has no help at all. Name is as, like there isn't a way to say, like, give me what I'm looking for as like the name of the method. Like when I generate the name of the method, that's actually a little complicated. I have that in other parts of Rocks where I'm actually generating what you see here in member identifier. That would actually be what I want. Because I think if you have something that takes here, yeah, you see that we get the return, we get the name, and we get this. And if there is because that's what we want. We want to get the name of it, the way you're seeing it here in member identifier, and that's what we want to compare on. So, how do I do that? How do I do that? I forget. So if I go into here and let's just say void value, it doesn't matter. Somewhere in here, member identifier. So I get method description. Okay. Where is method description? Yeah, it's a whole bunch of stuff up here. Like you got to get the explicit type name. You have to get the method. And you don't even know if it's an explicit type name, which I guess really wouldn't matter in this case, but We'd also have to get the return type here. So it is unfortunate that there isn't an ideal way to get the name of the, well, you know what? Actually, we could risk it for the chocolate biscuit, which is to say if the self.return type in this case get referenceable name is that, and then we look at other return type, and they would actually be the same. The name of it would be exactly the same, which arguably is what we want. Like if we look at the types here, and I know we're saying like if they're equal, but we would run into the same case of them being different if we had a parameter coming into the method based on the generic parameter that's defined on the method. And so we'd have the same issue. They come back as being different, even though they're going to be the same. So I'm thinking this might be the way to do it, but I'm a little concerned that I might be making too bad of an assumption here. But at the same time, I don't know of another way to say, hey, tell me what these really are, where the names of them should be what we're looking for. Like, here is the name. And that would mean too, like most of the time, like the name is going to be different. The number of parameters is going to be different. I also think we should check the number of type parameters as well. I believe that makes them different, that they don't match. So let's come back here. If I just had here like a public void, like I had foo of this int a, and that doesn't do anything. But could I also have a void foo of t? Oops. So now it's just telling me that t isn't used. Well, yeah, I could have like tt there, and that's perfectly fine. Those are actually two different methods, and so to call one, I'd actually have to specify the type. And of course, there's the case of what happens if I made tt here. Those are okay, but what happens if you actually want to call it with an int? And you do this, like there are some weird cases now that you do get into, but that's not the point. The point is the name of the type here would be int. This name would be int as well. I'm sorry, tt as well. And this is okay, but these are different, and I would need to generate for both of them. So I'm almost convinced now that we need to check the number of parameters as well. But then what we do is we actually look at the parameters, and what we're going to do is we still need to do these ref checks, but I don't think we want to check on the actual type. I think we want to check on the name, not the return type. Now, before I go any farther, do I have tests for this? Because I better have some tests for this. Match methods. So I do, and what I would want to do is add some tests in here to, and that's okay. Okay, we do in string void, and we're just looking for the method name. We don't care about how it's defined. We're just saying one is one is the other. And so we're actually not like saying, are they overridden or anything within a particular type? We're saying just, are they a match or not? Okay. And of course out, I actually have to do this. Oh, this would be a good time to update to raw string literals. But okay, so I think I have a strategy here now. So I'm still running, right? Or did I stop debugging? I think I stopped. Yeah, I must have. Okay. So yeah, you can see here, and I should push this over to match my standard. Okay, so I've already done it with a couple of these. Okay. And is there like convert to regular string? No, I want you to convert to a raw string literal is what I want you to do. Okay. That's what I want you to do. And yeah, let me just update one of these, and I'm not going to keep going through and updating all these because that would be a severe waste of your time and mine. So let's not bore you to death watching me put in curly braces. There we go. And of course push this over. But here's the point. What I want to do is have a couple of tests now. Match methods when methods differ by type, parameter, count only. Okay. So in here I would have that. Here I would have T. And what this should do is give me, it's not a match. Okay. I believe what this would do is actually give me, like if I ran this right now, it should give me that they do match. And so it would say that it's, oh, go away. Package host. Yeah, there's a problem, I think, with, yeah, the serialization thing with CSLA we don't want to do right now. Let's just comment that out. Let's comment that out. Okay. And let's close this. Let's come back here. Why do you care about package host? Oh, well, these do have to change, yes. But I don't think that would stop me. It might. Yeah, I think that's, it's showing me the errors from that, but there's really an error in here, and that was the problem. Okay. Now we should be able to run this. And it should fail. And it fails because we're saying, yep, it was exact. Okay, and so now we want to test to say, we want to match when methods are exact with type parameters and return type, because that's the case we're trying to solve here. So here what we're saying is we have method 1 that takes a T, okay, and we can throw in like a public class return type, which takes a T as well. Okay. We don't really care what that is, but we're going to say return type of T, because that's the T from there. And we're going to do the same thing here. Okay. And these should be exact. This is now giving us, if I remember what I'm doing, this is giving me differ by return type only. Okay. And what it's now and what we wanted to do is actually come back and say exact. And the reason why, come on, IntelliSense, you can, or whatever you are. Yeah, differ by return type only. And now if I run this, we should only get the 2 that are failing because we haven't changed anything yet. Okay. And we are. All right, now here's the moment of truth, which is if I come into here and I say self parameters, other parameters, we also want to say, you could also have a case, or could you? If I come back here and I say we have a foo of T bar, yeah, that actually it doesn't defines a member called foo with the same parameter types. Okay. Now, of course, I could now get into constraints, which is what happens if T is like, let's say I had public interface I stuff. We don't care what it is. Okay. But up here I say where TT is defined as being I stuff. It still doesn't care. Same parameter types. Okay, the types are just, so it's just the count. It doesn't care that you actually said that this is constrained to being, like maybe I had public interface another. Okay. And so now I say that this one is where T bar is constrained to be that. Still doesn't matter because it's saying same parameter types. Even, you could technically argue and say, well, these are 2 different or whatever. I don't know. But the point is that you just look at the count. Okay. So we say if self.type parameters is a type parameter, it returns an empty list, count, length. if that doesn't equal, yeah, then we would also say return method match none, because those are different. Okay, so now we are checking that. The self parameters are going to still be a little bit, because you could have type parameters that actually are being used, like the case with rock create, we don't actually use those type parameters. So now here's the change we want to do. If we say here, self.get referenceable name equals other parameter dot type get referenceable name. I'm saying that's so, oh God, don't. So we say end here. If they didn't equal, hold on, this, I think it was saying if they don't equal. So I think what we're saying is here is if these don't equal, or blah, blah, blah. And the same thing here. Now we want to say self.return type get name is equal to other return type. Come on, type. I am sure this is going to bite me. Quote me on this. This is going to bite me some way. If they match exactly by name, then it is an exact match. If they don't, then it's a differ by return type. Okay. So now here's the big test. Do we get 12 now? Or do we still get errors? Or do we get more? This is why having tests focus. This is why unit tests are good, because when they focus on specific things, you have to like run everything to see, well, what works or doesn't anymore. Now they all pass. So that's good. Now we can jump right to the program here and say, well, we just have that one. We just have the type. We may still get some errors with, we may still get some of these type T interface must be a reference type. That may still show up, but we should get rid of these first two, these 111 ones here. So let's see now what happens. And just because this works doesn't mean I broke something else somewhere else. I'd have to run and, do everything else again. Okay, well, how many do we have now? 7. I think that's much better than what we had. But we still have array defines a member called toString. So now we've got another problem. Now we've got toString coming in. So we actually got rid of a couple problems, but then we are now not matching toString correctly. And I bet this is also causing a whole bunch of bugs somewhere else. Like if you have toString defined somewhere else-ish, I don't know. So what would happen when we hit the toString? Okay. Because somewhere in here, I remember I was seeing toString come through twice. So let's debug this and see what happens. So we currently have nothing, and we find toString. So let's go through this again. We should have 1. This is equals. Okay. Hash code. And now we've got on get object, which we don't care about. So we should have 4 at this point, and we do. This is as, which we've now added. Now here's a toString. And what we want to find is when we have toString and toString, which is exactly what we have here. So do they differ by name? No, because they're both toString. Okay. Do they have different type parameters? No, they don't. Do they have a different count? Do they have any? No. So now what's the return type here? It's a string, and it's a string. So see? See? They differ, but not enough, if that makes any sense. In that if it's a nullable, we don't care. Yeah, I mean, this would also happen with the comparisons of the types up above. So I'm not sure that this is the right way to do it. I believe C# and when it says that they are different types, I'm not arguing that, but I have to handle this as though they are, because they are exactly the same. Now in this case, it's saying, well, they're different, and well, they are, but you can't do what I'm going to be trying, what ends up trying to happen, which is you're going to get two string methods now showing up, because it's going to say differ by return type only. So that's not what we want either. We want to say that they're exact. And I don't think, if I remember right, like if we come back here and just play with this, like you can't say public void bar, pass in a string, say A, okay, and just ignore A. But you can now say public void bar and say string question mark A. Like that's not different. And yeah, we could put in nullable enable, that's fine, and get rid of that problem, but it's going to say, yeah, the same parameter types. So these are exactly the same. Okay, so what we need to do here is say, like, if the type is nullable, which we don't have, nullable annotation. What we could do with nullable, we could say none, not annotated. Yeah, there does not equal. This is probably a little bit computationally expensive, but gives us what we would want, I believe. We do not want these to be Camtasia died again. I'm convinced it usually happens around 30 minutes. I don't know if it just like can't handle recording longer than that or what. I had no idea, but I saw it. Like I'm starting to be very aware of seeing this over there. And if I get really stuttery, that means it's about to crash. So I think I have to contact Camtasia again and say, this should not crash after just recording for 30 minutes, even though that's where I like to keep my limit, but I'm really close with this one. So get back into the mindset. What happens when I run the tests here? Because nothing should still break. Okay, and I'm going to put in another test here to say, well, match methods, match when methods differ by nullability, by parameter type nullability. Okay, because what we want to have here is like a string A, and then down here we want to have a string A. Except this should actually be considered exact. Because again, these are in two different classes, but we're just trying to compare the two. I'm glad I wrote this test, thank you me. And exactly, that's what we want, okay? And the same thing, we want to say differ by return type only, okay? Match when methods differ by return type nullability. So now what we want to say here is string and string, except this isn't going to take anything because we don't care. This is not going to take anything, we don't care. This should also be considered exact. Okay, cool. Let's run the program and let's see what we get now. 5, and I think it was 7 before, and if I come up into here, yeah, these are still something I have to look into, but this isn't the same thing. Now the last thing I'm going to do is I'm going to shut down and start up again, because does this break up a whole bunch of things that I was not expecting, like with generated code? So we're not done yet. Let's see what happens. Okay, it looks like this was a success, that we have all the tests passing. So we now have a fix for basically detecting inherited methods and making sure that the method matching is correct. So it feels a little squirrely with this null annotation getting the name, but I'm also perfectly fine with this, because I think, that this should be exactly what we're looking for. Because even though in my tests, I'm going from two different types, the names this is always going to be done from one type. So the way that the types are defined as the return types or the parameter types, I believe should always be like I said, if you had customer in one and customer in the other, they are exactly the same customer. Okay. And when you have a generic involved, even though they're considered different, they're considered to be the same, if that makes sense. Okay. So I'm good with this. I'm going to commit this. And now I'm going to go off and do a lot more investigation with all these other scenarios and cases. And I will make sure to catalog all them so that hopefully in the next episode is kind of a review of what I found. And hopefully I find some very interesting things. We'll see. So thank you all for watching. Leave comments and questions below. See you in the next episode.